This conference will now be recorded.
Okay, so you got this part designed in Rhino, and you don't have to worry about capping the bottom because the tool is not going to cut into through it because there's no gaps or holes, and this gap what you have is fairly insignificant because the tool may not be the gap is not too big for the tool to get in dive in there, right?
Right.
So first step is to get the part oriented correctly for machining, and also you want to make sure you're working in the correct unit. So if you need to rotate the part, you can use the tools that are available to you in Rhino, because if you try to put a stock around it, you're going to have a lot of material being wasted in here, right? Because this is not correctly oriented. So if I try to go into the RhinoCam machining browser, you'll see that there's a program and simulate tab, and there's three groups under each tab. You have machine, stock, and machining operations. So in the machine setup, you define the machining process where you're going to be doing a 2-3-axis machining. And if you have a machine that has a manual tool changer, you want to move to a tool change point, you can feed that information in here. Or if you have an automatic tool changer, you don't need to worry about it. The next step is you make a selection or choice for the post processor. As you pointed out, you have a CAM master. We have post for the WinCNC. We have the one for the X3, which is there called the XT Stinger machine. So we can have output in any of these formats in here. So if it's just a
okay, yeah, I have the X3.
X3, okay, you pick that. You can output in inches or millimeters, and then you can choose the extension NC or TAP or whatever they prefer for the extension. You can pick that from the list. Okay? And then you got to go through the process of defining the stock. If I try to put a stock in here, you will notice that it computes the minimum size required based on the orientation that you have. So it is 24, 25, and just under 2 3/4 inch thick, right? So you may want to orient it so you minimize the amount of stock you need for this part, right? So what you can do in Rhino is you can select it, and you can use the gumball in here. And if you want to rotate it, you can rotate using the gumball. I'm just doing a simple rotation in here.
Okay.
Freeform rotation, right? So I rotated the part. I can also move things around if I wanted to, but I'll just rotate it for now. Let's go back and try the stock in here. Now you can see we're down to about 15 inches or 16 inches in length, which is the distance on the X. And then the width can be 24, so you can save some material, right? And then the height can also be changed. If it's not level or if you need to rotate it, you can adjust it slightly to make it uniform. So let's go with a stock that's going to be 16 by 24. And give it a height 2 3/4 inch material.
Okay.
We'll accept that. So there's the stock defined. It says box stock. The next step is to basically align the stock to the part. So when you pick align, you can have the part centered in X and Y, so which means it leaves uniform material on all the sides. You can see it's leaving uniform material on all the sides. The part is centered, and then if you look at from the front view, you want to have it flush to the bottom so you can remove the material off the top. You can have it set to the top or to the bottom alignment. Okay?
Okay.
So that's pretty easy. You align it. And then the next step is you want to pick where you want to put the 0, 0, 0, which means when you throw this piece of material on your table, you want to do a touch off on one of these corners, preferably, or even in the center. So you can pick what corner you want to put the 0, 0, 0. We do that in several different ways. One of the easier ways to do set world coordinates. You pick set to stock. I can say higher Z, southwest, and select OK. This actually moves the part and the stock and puts your 0, 0, 0 right over here.
Okay.
Make sense?
Yes.
Okay. So now we are ready to start programming. We want to do some roughing and finishing operations. Now, would you be cutting this out of foam, or what kind of material would you be looking to machine it on?
Foam.
Foam. So you could go directly to a finishing process if you don't want to do a roughing, or you could start with the roughing process and then go into a finishing. So you go in and you pick a material in here. We have different types of wood. We have plastic. We can add a foam to the list of materials. That shouldn't be too hard. So this can be used for determining feet and speeds and also applying a texture during simulation. So we'll go ahead and add a roughing pass. We'll start with horizontal roughing. So this is included in standard configuration as well. You just have to pick a tool that you want to go with. So I could say I want to use a 1/2 inch end mill, a 3/4 inch end mill, so you can define tools as you go. You can set your feet and speeds. You can also load the tool from a library. So I have a library of tools that are currently loaded here, so I'm going to pick a 1/2 inch tool. Feet and speeds. You can set the clearance, the safety plane for all your non-cutting motions, transfer motions. And in the cutting, you can specify your cutting conditions, your step overs. In the cut levels, you can say how fine you want the tool to step. All you got to do is generate. You don't even have to pick any solids or surfaces or anything from the model. Those are only required if you want to restrict or contain the tool path to a certain area. So there's your roughing tool path. It's doing roughing in levels. So if you go to simulate and hit the play button, you'll see it's doing a roughing in levels. It's trying to hog all the material out. So that's a roughing process. You can always do a pause and hit go to end. And here you can see it shows like a collision. Basically, it's showing that the tool fluid is not long enough for the part. That's what it means. So it's marking the collision. So I can go back and update my tool. I can change my flute length to be at least 2 3/4. I can update my tool, go back and generate it. I can also change parameters, like I can make the step over, step down. I can change each of these parameters in here. I can say I want to go 40% for step overs. I can change my cut level to like 80% step down, so you can take more per cut. So now we have regenerated the tool path. I'm going to rerun the simulation. So that's doing a roughing process, roughing it in levels. You can always do a pause and then hit go to end. So there's your roughing process. Okay. The next step, if you want to do a finishing cut, you can go to a 3-axis finishing. You can start with like a parallel finishing operation. For this, typically you want to use a tool that has a radius to it. You can make like a ball and mill. You can set your feed speeds, clearance. In a cutting, you can specify your cut direction, cut angle in here. And then you can specify your step overs and then pick generate. So that's going to create a finishing pass on the part. You can also put a boundary to restrict the tool paths, contain the tool paths. You can always go back, and if you want to make a change, edit any of the parameters, generate it. That'll get you a tool path. And then you can go to simulate, run a verification. So that's a 3-axis parallel finishing cut. It follows the 3D model as you're cutting it. That's going parallel to the X, as you see right there, the cutter. I can change my angle of cut. I can go back in here and even put in an angle. Let's say I want to go at an angle of, let's say, 45. Give it an angle of cut, and that'll recreate your tool path. So it basically goes at a 45-degree cut pattern. Now you can see that some of the areas the tool path is falling down because it's there's some draft on the model. So one of the ways you can handle that nicely by not having to go down to the bottom is you can pick a boundary around the part. So I can go into, and I can pick these edges around the part right here as a boundary. I can go into the parallel finishing. I can just go pick those edges. So the edge can be used to contain the tool path, so the tool path will not fall past that edge. So you can use that as your area to restrict or contain the tool path. So now you can see it's not going down on the sides.
Okay.
And I put in the angle at 45 degrees, it's going at an angle of 45. And anytime you can always do a pause and then pick go to end, simulate to end, you can simulate it to the end. We also can do surface selections for machining. Let's say on this area, you only want to machine a certain area in here. You can go ahead and do a parallel finishing again. I'm going to do a copy paste, and I can select just part surfaces. I can just go pick this surface. I would like to machine this surface. I can just pick an individual surface, and I can choose the tool for it, and I can specify I want to go past the surface, and then I can change my direction of cut as well. Generate it. So that'll program a toolpath just for that surface right there. You can pick a surface to program it. So you have different ways how you can contain the toolpath. You don't have to necessarily pick a surface. You can also just put a boundary in here. For example, I could say my boundary can be like a curve boundary, which could be as simple as, let's say, I want to drop something up in here. So I can just throw in like a polyline, like a boundary right there. I can use that as my boundary to restrict the toolpath as well. So that'll contain the toolpath just within that area, as you notice it. And you can change how you want the tool to retract. So that'll give you a toolpath with fewer retracts in here. So now you have another final finish operation that you can create. And you can always change the angle of cut, the step overs, everything can be controlled. So that gives you a much finer finish over there. So you have precise control. Any questions, sir? Hello?
Sorry. It looks good. Now I got a question for you. Let's say this particular object.
Mm-hmm.
Okay. And now that we actually cut this object out, if I want to cut this object out of a larger, let's say a block of foam. So let's say this object we have in hand, and I want to be able to insert it into a block of foam. Let's say a piece of foam that is, let's say 28 by 18. Okay. How can I set on your settings to actually, cut out that object? I don't know how to explain it.
Foam that's just going to be as larger size, and you want to basically just cut this from the larger foam, right? Is that correct?
Yeah, I want to cut it out of the larger foam, so it's actually like recessed into a larger foam. So I want to take a 3-inch thick foam, and then take that object that's on the computer, flip it on its face. So the flat side is on the top of that 3-inch foam.
So it basically it's like a cavity.
Yes, I'm making it like a cavity. So I want that to fit into a cavity.
Okay, we can certainly do that. I'll show it to you. Now, before I get there, I want to also show you here, once you have these operations created, you can take a look at how long it's going to take to cut it based on the feet and speeds and all the parameters we put in. And then we want to do output it to the machine is right click and post, and that'll let you create your G-code output for it. So once you post it, it'll write out the G-code, and there's your code right there, which you can transfer to your CAM master machine.
Beautiful.
Okay. You can also generate a shop documentation like a report, so like a setup sheet. You can pick a folder where you want to put it. I'll just put it onto my desktop right now. So this will basically take a screen grab of the entire part, and it'll output it and open it in either you can do an Excel template or HTML template. There's different ways you can do it. So in this case, I did an Excel template.
And this also tells you the machining time, right?
Absolutely.
Yeah, there it is.
Absolutely.
Okay.
Okay. Now, let's go ahead and take a look at how we can do the cavity part of it, right? So I'm going to just basically get rid of this here for now. So we'll go ahead and flip the part over first. I'll flip it over 180, okay?
Okay.
All right. So now that we have it flipped over 180, I'm going to go ahead and create a boundary in here on this part. We have these curves that you have right there, right?
Mm-hmm.
Okay, can do what's called a curve boolean in Rhino. I'll just pick the curve right here. I'll just pick the outline. So it creates an outline around the part, as you see right there. Okay. And then you wanted to basically draw a sheet, right? What was the size of the sheet you told me, sir?
I think the sheet is 28 by 18 by
Okay.
3 inches thick.
18 by first corner is going to be at 0, and then 18 by 28. So basically, you see I drew a rectangle in there.
Okay, perfect.
Right? Okay, so now I can place the part wherever I want it to. I can basically I can specify where this needs to go. Like, for example, I'm going to put it right in here. Okay. All right. And so we can basically select these two, and I can cap this. And now I can select this and do a surface using a planar curve. So that puts a plane on it. You see, create a cavity right there.
Right.
And now we can go ahead and machine this. And this could be 3 inches or whatever thickness. I just go back and redo my stock. And all I'm doing is right-click regenerate. It's recomputing the toolpath. So we have the toolpath created for the cavity. And then I'm going to go back in here and then do the toolpath for this area right here. So now if I go ahead and run a simulation, we just did the cavity cutting, roughing operation. Then you got the finishing operation to clean up the cavity.
Okay.
Any questions?
No, not right now. I guess I'm gonna go and try to do this all on my own now.
Okay.
And I mean, you literally did that in like 5 minutes. Might take me a little bit longer. That's perfect. And you're gonna post this video?
Certainly. We'll get you a recording of this video, and also we'll edit and post it onto our YouTube channel. Once it's ready, we'll let you know. But we'll get you a raw recording of it as well.
Okay, awesome. Thank you so much.
Okay, give me just one moment here. I'm going to pause the recording.